welcome to the probability of equally likely events with qubits education. In this lecture, you will understand the likelihood of an event happening. You will use a probability scale to write down the likelihood of events, and you'll write down the likelihood of events from a two-way table. So, first of all, let's have a look at the probability scale. Probability is a numerical measure of how likely or unlikely an event is to occur. Probabilities are usually written as fractions, but can be written in any form equivalent to that fraction. For example, it could be written as 3/4 or as 0.75 or 75% because they're equal to 3/4. Probabilities can be anywhere between 0 and 1. So 0 would be impossible and 1 would be certain. So what is the chance that my dog will bite me tomorrow? Well, it's impossible because I don't own a dog. What is the chance that I will wake up tomorrow morning? Maybe it's certain. We don't know. But anyway, so that's how it works. So here is a probability scale. We have impossible, unlikely. Right in the middle, we have an even chance. Then we have likely and certain. And from that, we'll be able to say it's from 0, a half would be in the middle, and 1 is certain. This is also like saying 50% and 100%. So let's have a look at a question. An event with a probability of 0.8 would be described as very likely. An event with a probability of 0.4 would be described as unlikely because it's not 50%, it's less than 50%. So an event with a probability of 1/20 would be described as very unlikely because it's smaller. Okay, the bigger the number on the bottom of the fraction, the smaller the pieces that you get in. An event with a probability of 6/12 would be described as even chance because 6/12 is a half. If you'd like to pause the video now and have a go at these questions, try drawing out the probability scales and answering the questions, and press play for the answers. Okay, so if you've had a go, let's go through the answers. So first of all, we've got to complete this probability scale using the keywords given below. And the first one says the chance of getting an even number when rolling a dice. Well, on a dice, there are the numbers 1, 2, 3, 4, 5, and 6, which means there are 3 odd numbers and 3 even numbers, so it's a half because there's exactly the same amount of even numbers and odd numbers on a dice. B is the chance of winning the national lottery. Now, I would say that's either unlikely or very unlikely. Okay, so it might end up down here even. And the chance of rain in March is likely or even very likely. So we have impossible and certain here. So if we thought that the chance of winning the national lottery was unlikely, we could put it there. If we thought it was very unlikely, we could put it there. And then the chance of rain in March, if you thought it was likely, it could go there. And if you thought it was very likely, which in England it is, it could go here, or even closer. Now, here we had to describe an event that you think has a probability of 0.3, 1, and 0.8. So a probability of 1 would be something that's certain, like you getting a text message tomorrow, or something that's definitely going to happen. You know, the sun will rise tomorrow. That's a certain chance of that happening. 0.8, something that's very likely. Well, we could say raining, but we've already had that one. Something that's also very likely to happen, that I will wake up tomorrow and go to work. And then 0.3, something that's fairly unlikely to happen. It's unlikely that I'll get hit by a bus tomorrow. It's unlikely. I'm not saying that it wouldn't happen. I'm not going to jinx myself. Okay, so hopefully you understood all of those and you were able to get all of those right. If you didn't understand them, I hope you do now. So let's move on. So the probability of an event. The probability of an event occurring is defined as the number of desired outcomes divided by the number of possible outcomes. So for example, what is the probability of rolling an even number on a fair dice? Desired outcomes are even numbers, so that's 2, 4, and 6. So there's only 3 of them. The possible outcomes on a dice are the numbers 1 to 6. There's 6 numbers. So we would write the probability of the rolling an even number on a dice as 3, which would go here, out of 6, because that's the total possible outcomes. 3 out of 6 can be simplified to 1/2, which we've already seen on the previous slide. How about this example then? Feel free to pause the video at any point to have a go at questions that I'm going through. Mr. Brown puts all the pupils' names in a hat and picks one at random. What is the probability he picks a Year 11 student? Okay, so we can see here that we have 15 Year 11 students. Okay, so 15 of them. The possible outcomes are any pupil, which means we'd have to add up all of these, giving us 130 pupils. So the probability of picking a Year 11 student would be 15 out of 30, and we can simplify that to 3 over 26. If you're not sure on simplifying, please go back and watch the video on it because it's quite important for this. Okay, so why don't you pause the video then and have a go at a few of these questions and press play for the answers. Okay, if you've paused the video and had a go, let's go through them. Bob is picking randomly from a bag containing tiles numbered 1 to 10. Write down the probability that the number he picks is A, a 7, B, 4 or less, C, odd, and D, a multiple of 3. Well, we have 10 tiles. Try and imagine 10 kitchen tiles with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on them. Might help you. It says, what is the probability of you getting a 7? Well, if you look at your tiles on the wall, there is only 1 7. So it's actually 1 out of 10. For B, 4 or less, well, that's 1, 2, 3 or 4. So it must be 4 out of 10. An odd number. Well, you have 10 numbers, which means half of them are odd and half of them are even. So, my fault. This 4/10 can be simplified down to 2/5. So the odd one is going to be 5 over 10 because 5 out of 10 of them are odd, but we can simplify that to a half, which you might have already known. And finally, a multiple of 3. Well, we only have numbers 1 to 10, and in that set of numbers we have 3, 6 and 9, which is multiples of 3. So that's 3 of them out of 10. Okay? So, number 2, a survey is conducted of pupils' favourite teams. John picks a pupil at random to ask more questions. Write down the probability that the pupil he picks supports Liverpool. So if we look at Liverpool, we actually have 4 pupils out of a total of 30. Okay, we had to add all these up to get that number on the bottom, remember? So 4 out of 30 can be simplified to 2 over 15. What is the probability of him picking a London team? Well, as you can see, a London team says that it's 18 out of 30, and that's because 12 add 6 makes 18. Don't worry, they shouldn't really ask you a question like that about knowing which teams are London teams in your exam, so don't panic about that. But 18 over 30 we can simplify to 3/5. And then C is not a Liverpool team, so if it's not Liverpool, then we need all the ones that aren't Liverpool. So 12 add 8 is 20. Add 6 is 26. So it must be 26 out of 30, which can be simplified down to 13 over 15. And finally, number 3, a bag contains 20 coloured balls, some red and some blue. Keith knows that the probability of picking a red ball is 2/5. How many red balls are there? So we have a bag containing 20 balls altogether, and the probability of us picking a red ball is 2/5, okay? Or Keith picking a red ball, not us. Now, we need to get from 2/5 up to 20, so from 5 up to 20 on the bottom, because there are 20 balls. Okay, so 5 times 4 makes 20, which means I need to do 2 times 4, which is 8. So there must be 8 balls, because we need an equivalent fraction. Okay, and that is an equivalent fraction to this. Okay, so now, it's up to you if you want to pause the video for this one. I would like to go through it first, but if you want to pause the video and have a go, that's up to you. So if you have paused the video and you are going through the answers, that's great. If not, I'm just going to explain it anyway. So the table shows information about the number of goals scored by Aston Villa in each game of the season so far. Mr. Walker has all the games on DVD and decides to watch one. He picks a game randomly. What is the probability he picks a game with exactly 1 goal by Aston Villa? So, exactly 1 goal by Aston Villa. Well, one goal here, and it was in 6 games. So over 6 games, they only scored one goal one goal for each game. All right. So there's a total of 20 games, and if they scored one goal in 6 games, it must be 6 out of 20, which can be simplified to 3 out of 10. So, what is the probability he picks a game with 2 or more goals by Aston Villa? So, if we look at 2 or more goals by Aston Villa, here 2, 3, or more than 3, the number of games was 5, 4, and 2. Okay, so 5 games they scored 2 goals. In 4 games they scored 3 goals, and in 2 games they scored more than 3. And altogether we have 5, 9, 11. So it's 11 out of 20. Okay. And finally, this cumulative frequency curve shows the distribution of the height of 50 students. Estimate the probability that a student picked at random will be more than 164 centimetres tall. Now on this one, what we have to do, and we will do cumulative frequency graphs in more detail, but we need to go from 164 on the bottom of the graph up to the curve and across to see where it hits. So it's asking us, estimate the probability that a student picked at random will be more than 164 centimetres tall. Now, be careful because you're not writing 40, you're writing whatever's left from 40 up to the end of the graph. And the end of the graph is at 50. So there's only 10 left, okay? 10. So 10 over 50 because that's the total, which can then be cancelled down to 1/5. Or written as 20% if you want to. This one can also be written as 30%. This one could be written as 55%, but that's up to you if you want to write them as percentages. Okay. So now this one's a little bit tricky. If you would like to pause the video and have a go, please do, but I will explain it anyway. Okay, so if you've had a go, let's go through it. After playing 500 games, my success rate at Angry Birds is 49%. Assuming I win every game from now on, how many extra games do I need to play in order that my success rate increases to 50%? And these are your options for your answers. 1, 2, 5, 10 or 50. Now, first of all, we need to work out 1% of 500, which is 5. So 49% is 245 games so far. If 1% is 5, 49 times 5 is 245. Okay, so far 245 games won. If I win one more, this gives me 246 wins out of 501 games. If you put that in your calculator, you will notice that it does not come to 50%, which is what we are looking for. If I win 2 more games, this gives me 247 wins over 502 games. And if you do 247 divided by 502 on your calculator, you will see that it is not equal to 0.5, which is not equal to 50%. If I win 5 more, this gives me 250 over 505 games, also not equal to 50%. But as you can see, I'm just trying to go up in a pattern to see if I can get that equal percentage. So, if I win 10 more games, this gives me 255 wins over 510 games, meaning that that is equal to 50%. So it means I need to win 10 more games, or play 10 more games, okay? Okay, so let's move on then to total probability of events. Now, the total probability of events gives you this really difficult rule to learn, but all you need to understand is that all probabilities add up to 1. So this rule, if one of a set of possible outcomes, x subscript I, must happen, then the sum of the probability of all of these events equals 1. These possible outcomes, equals 1. Okay, so this symbol here means sum of, and this is your event that we don't know what it is yet because this rule applies to every single probability. So we use these letters to help us to use them for every single type of probability that we'll come across. So basically, the sum of their probabilities is 1. That's all you need to know. So for example, the probability of rain today is 0.7. So the probability of no rain is 0.3. Okay, so let me just explain that one more time. So the probability of rain, the probability that it will rain is 0.7. The probability that it won't rain is 0.3. 0.7, or if you want to think of it in terms of money just to help you with adding, 70 pence add 30 pence makes 100 pence, or 70% add 30% makes 100%. So 0.7 plus 0.3 must equal 1. Here's another example. A coin is biased so that the probability of heads is 3 over 5, which means the probability of tails must be 2 over 5. There are 5 in total, 5 outcomes in total. Okay, 3 of them will be heads, which means the other 2 must be tails. A 4-sided spinner has the following probabilities of getting each number. The probability that the spinner will land on 2 is equal to the probability it will land on 4. Complete the table. Okay, well, first of all, we have 0.2 and 0.3. Okay, and then we have these x's. And we know that 0.2 plus this plus 0.3 plus this gives us 1, because all the probabilities must add up to 1. Well, that means we have 2x and we have 0.5, because 0.2 and 0.3 make 0.5. And that is all equal to 1. We can then work backwards, and you've all done equations, so there should be no problem with these. Okay, if you haven't watched the video on equations, please go back and do so. We can then reverse our equation, so we can take away 0.5, okay, from 1, and that means that 2x equals 0.5, because 1 take away 0.5 gives us 0.5 left. And then we can divide by 2, so x must equal 0.25. Okay, so why don't you pause the video then and have a go at these questions. Okay, if you've had a go, let's go through the answers. A die is biased so that the probability of rolling a 6 is a quarter. What is the probability of not rolling a 6? Well, there must be 4 options altogether. If one of them is rolling a 6, then 3 of them must not be, because you need to do whatever's left to get to the 4. So we've got 1, we need 3 more, so 3 goes on top and the 4 stays on the bottom. Or 1 take away a quarter, or 100 take away 25. Okay, gives me 75% or 75 pence, which is equal to 3 quarters. A die is biased so that the probability of each number is as follows. Find the value of x. So here we've got 1, the number 1, the probability of getting the number 1 is 0.1. The probability of getting 2 is 0.15. We don't know the probability of getting 3. The probability of getting 4 is 0.2. We don't know 5. And the probability of getting a 6 is 0.5. So all you need to do is add all of those together, okay? So it's just reminding you here, this is the rule. It's hard to remember, I know there's lots of symbols, but all it means is that they all add up to 1. So if you see this in the future, that's what that means. So let's write them all down. We've got x and x, so we've got 2x, and then all of these added up makes 0.5. So 0.5 plus 2x equals 1. It's easy enough, isn't it? Take away 0.5, okay, so you need to get rid of this, take it away, and then divide by 2, leaving us with x equals 0.25, similar to the last one. And finally, the weatherman claims that it is twice as likely to snow as not. Complete the table. So because it's twice as likely, 2 needs to go on the twice as likely to snow and 1 on the not snowing part, and because the 2 and the 1 add up to 3, then 3 must go on the bottom of your fraction. Okay, so I know this is kind of getting a little bit long, but I just want to go through this type of probability event with you. So we have a horse racing game, and it says that each horse moves 1 square if you get its total when you roll both dice. Is it a fair race? So it isn't fair, and the reason that it's not fair is because what that game is telling you is that if you roll 2 dice and you get its total, okay, you add it up, okay, that's how you win. So consider the possible outcomes from finding the total of 2 dice. So what you need to do here is you need to add up all the numbers. So 1 add 1 is 2, 2 add 1 is 3, 3 add 1 is 4, 4 add 1 is 5, and so on. And then we do 1 add 2, and 2 add 2, and 3 add 2, and 4 add 2, and 5 add 2. Then we do 1 add 3, 2 add 3, 4 add 3, and so on until we get to 6 add 1, 6 add 2, 6 add 3, all the way to 6. So you are rolling 2 dice. This is your first dice, then all the options, well, all the outcomes that you could get, and this is your second dice, okay? And don't forget that the probability is the number of desired outcomes divided by the number of possible outcomes. So let's have a look how fair this game is. So you can either get a total of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12. They are your options of answers. So the total of getting a 2, the probability of getting a 2 is only 1 out of all of these results. So it's only 1 out of 36. So if your horse is called 2, then you've hardly got any chance of winning. But then again, if they did win, it would be high stakes. Okay, so the chance of getting a 3, well, there's only 2 of those, so that's 2 out of 36. The chance of getting a 4, 3 out of 36, and so on. And it's just going to increase until it gets to the middle. So I think 7 will be your highest. Okay, so 7, there are 1, 2, 3, 4, 5, 6 out of 36. And then 8 is when it starts to go down again, back to 5. And then 9, there's only 4 options. 10, 3 options. 11, 2 options. And 12, 1 option. Okay, so as you can see, your best bet is number 7. Okay, that's the highest chance of winning if you bet on number 7 to win. Okay, so 7 is the most likely total, so horse 7 is most likely to win. Okay, 2 and 12 are the least likely totals, so horses 2 and 12 are least likely to win. Okay, so why don't you pause the video and have a go at this question and see if you can work out some of the answers. Okay, if you've paused the video and had a go, let's go through it. In a game, 2 fair dice are rolled and a score is found by multiplying the numbers obtained together. Show the possible outcomes in the table below. Okay, so you should have already done that. Let's get them in. You then need to use your completed table to find the probability of getting a score of 12 Okay, so don't forget probability, number of desired outcomes over the number of possible outcomes. You've got to find the score of 12, so we need to highlight all the 12s. 1, 2, 3, 4. Okay, I think, yep. 4 outcomes out of 36, okay, that give you a score of 12. 4 out of 36 can be cancelled down to 1/9. Now, because there's 6 numbers here and 6 numbers here, we know that there will be 36 different outcomes because they're 6-sided dice. 6 times 6 is 36. And then finally C, use the table to find the probability of getting a score of 23 or more. So 23 or more, we don't have a 23, we only have 24, 25, 30 and 36, which is 6 outcomes, so 6 out of 36, which can be cancelled down to 1/6. Okay? Good. Right, then, almost there. If you would like to have one more go at this one's a little bit different. They are spinners, not dice, so be very careful. Pause the video and have a go. Press play for the answers. Okay, if you've had a go, let's get through this. In a game, 2 fair spinners are spun and a score is found by adding the numbers obtained together. Show the possible outcomes in the table below. Okay, so this one's quicker because we only have 4 numbers. So 1 add 1, 2 add 1, 3 add 1, 4 add 1, and then 1 add 2, 2 add 2, 3 add 2, 4 add 2, and so on until our table is full. Now, B, use your table to find the probability of getting a score of 7. Okay, well, as you can see, we only have 2 sevens, so that's a score of 2. And we have actually 16 possible outcomes because 4 times 4 is 16. So that would be 2 out of 16, which is 1/8. And then C, find the probability of getting a score of 4 or less. Well, we have 4, 4, 4, 3, 3, 2. So that's 1, 2, 3, 4, 5, 6. 6 outcomes. Okay, so 6 out of 16, which is 3 out of 8. Okay, so well done if you got all of those right, because we're getting to a point where you've got to try and remember a bit more information. Okay, so I will just go through this one because it's a little bit different, okay? So Keith has 3 coloured balls in a bag. He has red, blue and yellow. He picks one, records its colour, but puts it back and picks another one. Complete the table to show the possible outcomes. Okay, so write down the probability that Keith picks the following. So we need to finish the table first. Okay, so RR, okay, RB or BR, and YR. So here this must be BR or RB. This must be BB, okay. This must be YB because you've got YB, and then RY, BY, YY. So you've filled it all in. 2 balls of the same colour. 2 balls of the same colour. What is the probability that Keith picks 2 balls of the same colour? Right, well here they've got red and red, blue and blue, yellow and yellow. So it must be 3 outcomes, and don't forget it's only 3 choices on each one. So it's 3 times 3, which is 9. So it's 3 out of 9, okay, which is actually 1/3. Okay, and then the second one, 2 balls of different colour. Okay, so 2 balls of different colour, meaning that that's this one here, that's different, that's different, that's different, that's different, they're different, they're different. So different to each other. So we can't choose that one because they're both red, whereas this one they've got a blue and a red. So that actually gives us a probability of, so 1 minus 1/3, because all you're doing is saying, well, the rest of them, it's the rest of them. So if these are the ones with the same colour, the rest must be different colours, okay? So if that's 1/3, then the rest must be 2/3, okay? Because we have to have what's left to make this a whole one, okay? 2 add 1, make 3. Okay, at least 1 yellow ball. So at least 1 yellow ball. So there's 5 outcomes here. So we have 1, 2, 3, 4, 5. Okay, 5 ones with the yellow in. All right, so 5 out of 9 for that one. Okay, so there's a lot that I've gone through there, and if you need to watch the video more than once, please do. I know that you now understand the likelihood of an event happening, and I'm sure you will show me your understanding when you do the quiz or the assignment. Use a probability scale to write down the likelihood of events. We've definitely gone through that. And write down the likelihood of events from a 2-way table. You've definitely done that. Now they're quite common in the exams. The exam writers, or the people that write the exams, do love those kinds of questions. So be prepared for them, okay? But anyway, well done. You've done very well. Thank you so much for using Cuba Education, and I'll see you next time.